In this class, now I am going to explain you trigonometric functions. Let us begin with sine function. Let us consider y equal to f of x is equal to sine x. Okay, as you know, this sine function will be defined in the entire real number set. See, let us see whose graph. X dash, y dash. Here take 90 degrees, here 180 degrees, here 3 pi by 2, and here it is 2 pi. Here it is 5 pi by 2. Now left side of origin, here you will get minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on. And on the y-axis take here 1, here minus 1. As I said to you, sine function will be defined on the entire real number set. So you know how to draw the graph of a function. So we take the domain on x-axis and whose respective range we consider on y-axis. Okay, so if you observe the graph of the sin x in the interval minus 90 to 90, you get like this. If you write domain value x equal to 90, as you know, sin 90 value is 1. Here domain is 90, range will be 1. So between this origin to 90, you get the sine graph like this. Okay, from minus 90 to 0, when you put x equal to minus 90 here, as you know, sine of minus 90 is equal to minus 1. So you get the graph like this. Between the minus 90 to 90, we get like this. So it is strictly increases from minus 90 to plus 90. So from 90 to 180 degrees, when you take domain value from 90 to 180 degrees for x, so you get the graph like this. Similarly, if you put x equal to 90 degrees, here 270 degrees here, as you know, sine of 270 minus 1. So range will be minus 1. So from 270 to 360 degrees, you get the graph like this. 270 to 540, you get like this. It will go. So left side also, you get the graph like this. So in this interval, it attains maximum at 270. See here. This is the graph of sine function. So observe this graph. How it is oscillating between minus 1 and 1. See, increasing from minus 90 to 90, strictly increases. Again 90 to 270, strictly decreases. And 270 to 540, strictly increases. Okay, increasing, decreasing, increasing, decreasing. So left side also. So how it is oscillating between the minus 1 to 1. And where it is defined on the entire real number set. Hence, the domain of this sine function is set of real numbers, and range is close interval of -1 to 1. See here, -1 to 1. If you draw a horizontal line through the 1 and through the -1, so here this horizontal line will touch the sine curve at these extremes. So where this range is attaining maximum at this here 90, 5 pi by 2, -3 pi by 2. At these values, this sine function is maximum. How much is that maximum value? 1. And where it is minimum? Here -90, 3 pi by 2, and so on. So completely this sine graph is oscillating between -1 and 1. So here also, if you would like to draw the horizontal line through the -1, you can. Okay. So between this y equal to, here what is the name of this line? Y equal to -1. What is the name of this line? Y equal to 1. So whose graph is oscillating between -1 and 1, hence whose range is -1 to 1. And the domain is set of real numbers. Okay. Now let us go to the principal domain. Okay. Here you have to know one thing. What is meant by principal domain? Principal domain is a domain where the function is bijective. Okay. So bijective means you know that function should be 1, 1 as well as onto. So here we consider this interval -90 to 90 as principal domain for sine function. So what is the principal domain? Principal domain of sine function is closed interval of -90 to +90. Remember this point. So in this interval, this graph is strictly increases. So in whichever interval graph of a function strictly increases or strictly decreases, so in such interval that function will be bijective. Actually this sine function is strictly increases, strictly decreases in many more intervals. But the mathematician who was written this trigonometry said that this interval as principal domain, so that we people will consider this interval, okay, in which origin includes, is known as principal domain. Okay, right. Next to, okay, where this function is attaining a range as 0. See here, 0 degrees. Respect to range, 0, 0 comma 0. Here, domain is 0, range is 0. Go here, pi comma 0. And here, 2 pi comma 0. Here, minus pi comma 0. Here, -2 pi comma 0, and so on. Okay. So suppose if I give you this equation, sin x equal to 0. Now solve this equation. If I give you this question, solve sin x equal to 0, means what do you say? What are the solutions for this equation? X equal to n pi, where n belongs to integer. So sin x is attaining, result is 0 at x equal to n pi, where n is an integer. Either it may be positive or negative integer. Okay. So observe, see here, where this curve of the sin x is intersecting the x-axis at this particular values. Okay. So if this equation is given, then what do you comment on whose solution? X equal to n pi. Okay, right. And also observe this sine function. It is a periodic function. How you people can say whether it is a periodic function or not? See, actually what is meant by periodic function? If the graph of a function repeats in its domain then such function is known as periodic function. Is the sin x is a periodic function? Yes, because observe in its domain. So here, observe from the origin. Here, you got one crest from 0 to pi and pi to 2 pi, one trough, one crest, one trough. Okay, so hereafter, after 0 to 2 pi, again you are getting one crest and one trough in the regular intervals. So 0 to pi, observe this graph and observe from 2 pi to 4 pi. So you are getting one crest from 0 to pi and pi to 2 pi, one trough, again crest, trough. Okay, after how much length of interval this is, okay, graph of the sin x is repeating? 2 pi length from here to here, 2 pi. Hence, it is a periodic function with period 2 pi. Period is 2 pi radians. Remember that point. Okay. So now what we have seen here? Graph of the sine function and whose domain, range and principal domain and period of this sine function. Okay. Right. But every time. Okay. So here it is a basic function so that we people are in the position to draw the graph of the sine function. But if the complexity of the function increases, so drawing the graph of such functions is somewhat difficult. Hence we have some procedure to identify periods of that functions. Suppose if I give you sine of 3x. Now how do you find whose period? Sine function graph, you know, we observe whose graph in its domain, that graph was repeated. Hence we said, okay, it is a periodic function with period 2 pi radians. But if the function is given like this, drawing this function, graph of this function is okay, somewhat complex. Hence, how do you determine whose period? Here we have some procedures, okay, to find periods of the given function. Let us observe that, okay, procedure. See here, f of x is a name of the function. Okay, suppose if a function satisfies f of t plus x is equal to f of x, then that function is known as periodic function. F of x is a one function. That function can be any function. You know, in the mathematics there we have infinitely many functions. For example, inverse functions, logarithmic functions, trigonometric functions, algebraic functions, exponential functions, composite functions, like many more. Okay, so if a function satisfies f of t plus x equal to f of x, then that function is known as periodic function, where t is called period of the function and t should be the least positive real. Okay, so for example, if you take f of x equal to sin x, so now f of 2 pi plus x, simplify this, sin of 2 pi plus x. Now sin 360 plus x, sin x. Same function is repeated. Okay, not only at 2 pi, if you take t is equal to 4 pi plus x, you will get sin of 4 pi plus x is also going to be sin x only. Not only 4x, like 6 pi, if you assign t equal to 4 pi, 6 pi, 8 pi, at many more places, it is going to be repeated same function. But among all that, so the smallest one is 2 pi. Okay, na? As I said to you, t should be the least positive real. Okay, so among all this, 2 pi is the least positive real. Hence, we have to say the period of this function is 2 pi. Okay, so suppose if the function is given like this, sin of ax, where a is the coefficient of x. A can be either positive or negative. Then you have to say whose period is 2 pi radians by mod a. Okay. So suppose if the function is given like this, mod sin x. If you go for the graph of mod sin x, okay, you know absolute value of a real number is always positive, no? So just now you observe the graph of the sin x. One crest we got, one trough we got. Okay, from 0 to pi, like that and so on. But here, negative range will not come. If you see the graph of this mod sin x, so it will come like this, 0 to pi, and pi to 2 pi, and 2 pi to 3 pi, 4 pi. So, like this it will go. Okay. So, from -1 to 1, 0 to 1 only whose range will come. We get, if you draw the graph of mod sin x, you get the graph like this, okay, which comes in the interval 0 to 1 only. Okay, so here this width will be pi. So after how much length of interval this graph will come? Pi, not 2 pi. Okay, here mod is there, no? So that it repeats after pi length. Okay, hence we say the graph of this mod sin x is pi. So sometimes x coefficient may be a given. Suppose here ax is given. What you have to write? Pi by mod a. Okay, right. Now suppose if the function is given like this, sin power nx. Okay, whose period is pi if n is an even. N is an even integer. So it is equal to, this period will be 2 pi if n is an odd integer. Okay, right, observe this. Now, let us see this. Suppose, how do you solve this equation? Solve sin x is equal to, okay, sin alpha. Sin x is equal to sin alpha. One equation is given. Otherwise, sin x equal to k, where k is lying from -1 to 1. How do you solve this trigonometric equation? You know, it is an equation involving with trigonometric ratios. Hence it is called trigonometric equation. Now solve it. Okay. How do we solve this sin x? And this k you have to express in terms of sin. Let it be sin alpha. Okay. Observe that where alpha belongs to principal domain of sin function, and bring it to the left side. Sin x minus sin alpha, which is equal to 0. It is looking like sin c minus sin d. So that, okay, if you write okay, that transformation formula, then what do we get here? 2 cos a plus b by 2 sin a minus b by 2, which is equal to 0. Right. See here, the product of these two things equal to 0 means, okay, either you can equate this one equal to 0 or this one equal to 0. When you equate this one equal to 0, so here cos of x plus alpha minus 2 is equal to 0. And this one, sin of x minus alpha by 2 is equal to 0. Right. Now, you know, just now we have seen where this function is going to be result as 0 when x equal to n pi. Okay. So here x minus alpha by 2 So is equal to, write here m pi, where m belongs to integer. Now x is equal to, what do you get? 2m pi plus alpha. Here also, where do you get cos x is equal to 0? When x is odd multiple of 90. Okay, so now here x plus alpha by 2 is equal to, write it 2m plus 1 into pi radius by 2. This is a standard form of an odd number multiplying with 90 degrees. Hence we get odd multiples of 90. If you assign this is equal to odd multiple of 90, result will be 0. Now simplify this. So x is equal to 2m plus 1 pi radius minus alpha. Okay, so when here m is an even number, so you get this one as solution for the given equation. When m is an odd number, this one will be the solution for the given equation. If you put two together, then you will get the general solution will be like this: n pi plus minus 1 whole power n into alpha, where n belongs to an integer and alpha belongs to principal domain of sine function. So this is the general solution of sin x is equal to k, where k must be minus 1 to 1. Okay, n pi plus minus 1 whole power n alpha. How did I write this? With the help of these two only. If n is an even number, you get this one. If n is an odd number, you will get this one. So I kept it together so that we get like this. Remember this formula: n pi plus minus 1 whole power n into alpha is the general solution of that sin x equal to k. Now let us see one problem. See, sin x equal to 1 by 2 is given, suppose. Now solve it. Okay, you know, when you assign x equal to 30 degrees, sin 30 will be 1 by 2. Okay, but in one rotation. But see, no means here in the first quadrant, 0 to 90, if you take x equal to 30, you will get 1 by 2. If you go to the second quadrant, you know, sin is positive in first quadrant as well as in second quadrant. If you put x equal to 150 degrees also, result will be 1 by 2. Okay, na? So at x equal to many more real values, the sine function will be going to be given 1 by 2. Okay, how do you write all those solutions? Means, okay, from this formula only, x is equal to n pi plus minus 1 whole power n alpha. Okay, right. So see, first what you have to do, this you have to express in terms of sine. Okay, sine of pi radians by 6, 30 degrees. Now identify the alpha value. Alpha equal to pi radians by 6. This is the principal solution. You know, which we have to write from the principal domain. What is the principal domain of sine? Minus 90 to plus 90. So in, okay, for which value of alpha it is going to be 1 by 2? 30 degrees. Okay. Now collect that 30 and come back and write over here. Now x is equal to n pi plus minus 1 whole power n pi radians by 6. Okay. So this is the general solution of this given equation. Okay. Now let us go to the cosine function. So for this sine function, what I have discussed with you, whose graph, domain, principal domain, range, and whose general solutions for sin x is equal to 0. We got x equal to n pi. and if sin x equal to k, general solutions x equal to n pi plus minus 1 whole power n into alpha. Okay, and also it is a periodic function with period 2 pi. Okay, now let us discuss same things for cosine function. So first let us draw the graph of cosine function. Now let us take y equal to f of x is equal to cos x. Now this cos function graph also will come same like sine. See, right, when we put x equal to 0, okay, now what is the domain of cos x? Even cos x also will be going to define in the entire real number set. Okay, so x axis means what? Horizontal real number line. I am taking domain values on x axis. Okay, so now when you write x equal to 0, cos 0, 1. So domain is 0, respect to range is 1. Similarly, when you write x equal to 90, cos 90, 0. So from 0 to 90, so cos graph will come like this. From 90 to 270. So range of cos is negative now. You know cos x is positive in first quadrant and fourth quadrant. So 90 to 270 means second quadrant. Second quadrant negative. So you get the graph like this. When you put x equal to pi, cos pi minus 1 will come. So from 0 to pi you get the cos function graph like this. Similarly from pi to 270 you get like this. For 270 to 360 in fourth quadrant range will be positive. Positive means above the x-axis you will get. Negative means below the x-axis you will get. See here, it will go like this. So left side you get like this. This is the graph of cos x. Okay, same like a sine function graph you get, but that sin x graph of sin x passes through the origin, but whereas cos x graph will not passes through the origin. Okay, all right. Now comment on its domain. So cos function is also defined on the entire real number set, and where range is close interval of -1 to 1. Okay, now so 0 to pi is the principal domain. What is principal domain? 0 to pi, because in which the graph of cos x is strictly decreasing, hence it is bijective. Bijective means inverse of that function is possible. That function is invertible in its principal domain. Okay, so here 0 to pi it is strictly decreasing, hence okay, so this interval is called principal domain for cosine function. Actually at many more places it is strictly increasing, strictly decreases, but okay, so we consider this interval only principal domain because that mathematician was given like that, so that we people are following. That's it. Okay, right. Now is this a periodic function? Yes, because whose graph is also repeating after 2 pi length of interval. See, you start from here, 90 to 90 one crest came, and 90 to 271 trough. Crest trough, how much length from here to here? 2 pi now, So again crest trough 2 pi length interval. So hence it is a periodic function with period is 2 pi. Okay, right. Next. So observe this graph, and where it is attaining result as 0 at odd multiples of 90. So suppose if cos x is equal to 0 is given, what do you comment on the general solutions of x? Where that curve of cos x is intersecting the x-axis at odd multiples of 90, x equal to 2n plus 1 into pi radius by 2, where n belongs to integer. Okay, right. Now suppose cos, okay, find the domain of, find the period of cos x is cos ax is given. What do you comment on whose period? 2 pi by mod a. Okay, similarly, so mod cos ax is given, whose period is cos ax, or cos mod of cos ax is equal to pi by mod a, pi radians. And every time here I am not writing apostrophe as c, you write. Okay, so now cos power n x, so whose period is 2 pi if n is an odd integer. This period is pi if n is an even. Okay, right, remember these points. So suppose, how do you solve this equation? If cos x is equal to k, where k value is lying between -1 to 1. So what you have to do? You have to express this k in terms of cos. Let it be cos alpha, where alpha belongs to principal domain of cos 0 to pi, and bring it to the left side. Cos x minus cos alpha is equal to 0. It is looking like cos c minus cos d. Now apply that cos c minus cos d formula. Minus 2 sine c plus d by 2 into sine c minus d by 2, which is equal to 0. Now transfer minus 2 to the right side, so that what do you get here? See, sine of x plus alpha by 2 is equal to 0. Sine of x minus alpha by 2 is equal to 0. Now where do you get this range as 0? For angle belongs to n pi. Here also x minus alpha by 2 is equal to n pi or m pi. Take m belongs to integer. Here also take m belongs to integer. Now simplify. X equal to 2m pi minus alpha. Here x equal to 2m pi plus alpha. Now put together, so that, so here 2n pi plus or minus alpha, where n belongs to an integer and alpha belongs to closed interval of 0 to pi. So this is the general solution of cos x equal to k, because cos function will be given range as k at many more values of x. What are those values? 2n pi plus or minus alpha. Like this we have to solve that cos x is equal to k equation. Okay, right. Now let us go to the tangent function. Right. See, y equal to f of x equal to tan x. Now let us observe the graph of tan x. So how do you get graph of tan x? See this. Origin, here it is pi by 2, here it is pi, 2 pi, 3 pi by 2, now this is pi by 2 and minus pi, minus 3 pi by 2 and here minus 2 pi and so on. Because all these are real numbers only. Pi means approximately 3.14 by 2. So 1.7 you will get. Okay. These are irrational numbers. Okay. Now range you have to take on y-axis. Okay. Alright. Now observe this tan x graph. If you put domain value 0, tan 0, 0. Okay. And 0 to 90, if you observe the graph of tan x, you get like this. From minus 90 to 0, you get the graph like this. But if you draw any vertical line through the minus 90, through the plus 90, so that vertical lines should not intersect or should not touch the graph of tan x. Okay. So tan x graph will go like this. From minus 90 to 90, strictly increases. Okay. If you draw the two vertical lines through the minus 90 and plus 90, that vertical lines must not touch or intersect this graph of tan x. Okay. Similarly, 92 here 270. Here 2 pi will come. Okay. So 90 to 270. See, you get like this. Here also, if you draw two vertical lines through the 90 and through the 270, again should not touch or intersect the graph of tan x. Again, it comes like this. So from minus 90 to 270 also. So this is the graph of tan x. Okay. So now tell me where it is defining. At odd multiples of 90 we are not producing any range. Hence, so tan x will not be defined at odd multiples of 90. See here, tan 90, minus 90. Here we are getting breaks for the graphs, no? These graphs are not continuous in the entire domain. Where you are getting breaks? At odd multiples of 90. Where the tan function is discontinuous. Graph is not possible. Range is not possible. Hence, what do you comment? This is a discontinuous function at odd multiples of 90. Okay. Now see whose domain. R minus 2n plus 1 into 90, where n belongs to z. That is the domain of tan x. So principal domain is minus 90 to 90. Okay. So what is the principal domain? Principal domain of tan function is open interval of minus 90 to plus 90. These extreme values are not included. Okay. So that will be the principal domain. And whereas range, pi radius here. So from minus 90 to 90, pi. So graph got like this. Again in the next pi, 90 to 270. Length is pi. So same graph is repeating. Next, in the length of pi, you get the same graph. The graph of tan x is repeating. Okay, after pi length. Okay, hence whose period will be pi radians. Yes or no? The graph of tan x is repeating now after how much length of interval? Pi. Hence it is a periodic function with period pi. Right. Now, okay, where it is attaining result as 0, tan x is equal to 0. Now solve it. So for which value of x result is going to be 0 means observe the point of intersections of curve with x axis. Here it is 0 range. Here it is 0. Here it is 0. Here domain values 0, pi, 2 pi no. So hence x equal to n pi where n belongs to z only, integers. Okay, right. Now what are the general solutions of tan x equal to 0? X equal to n pi. Okay. Suppose if the function is given like this, so tan ax, then whose period will be pi by mod a, same like the sine and cosine functions. Now if tan x is given, period will be pi. If x coefficient a is given, by mod a you have to write. If tan power nx is given, whose period will be pi only, if n may be an odd integer or even integer. Okay. Now suppose f of x is a one function amma, whose period is so and so. Okay. Suppose take whose period is t, and f of 1 by x, so whose period will be t only. No changes will come in its period when you take the reciprocal of this function. Okay. Okay, observe this point. The period of this function is t, then the reciprocal of this function period will be also t, but 1 by t will not come. Now, okay, let us solve this tan x equal to some k, where k belongs to any real number. Now how do you solve this equation? Now tan x is equal to this k, you have to write as tan alpha. Now, okay, express this in terms of sine and cos. So sine alpha by cos alpha. Now take cross multiplication. Sin x into cos alpha. So cos x into sin alpha. When you bring this one left side, so you get sin of x minus alpha is equal to 0. Okay, you know, okay, what are the general solutions of sin x equal to 0? X minus alpha is equal to n pi. Now x equal to n pi plus alpha, where n belongs to an integer. Okay, so these are the general solutions of tan x equal to k. Okay, now what we have seen till now, we have seen the basic trigonometric functions sin x and cos x, tan x. Now let us go to whose reciprocal functions like cosecant x, secant x and cot x.